Hey everyone, I'm Mike Brightman. My company is Brightman Designs, and I design homes in Denver, Colorado using SketchUp Pro layout and my Condoc Tools extension. I'm also the author of the SketchUp workflow for architecture, arguably the best SketchUp workflow book ever written. And I got John Brock with me here today. John, what do you think about
What's
that?
up, Mike? I have to concur. So I'm John Brock. I'm a custom builder and designer, SketchUp junkie like Mike, SketchUp author, SketchUp for builders. And have several SketchUp extensions that I developed over the years, like Estimator, PDF Importer, Framer, new one called Spot. So anyways, long friends with Mike, and we're going to have some fun.
Absolutely, man. Yeah. So we teamed up to do this presentation for Basecamp 24 in Vegas, and thought we'd take a run through it and show you guys what we got. So let's get started. So this is a project I worked on in Denver, recently completed, and massive renovation, a pop-top renovation where we pull the roof off of an existing house. So this is the house as it stood when I started the project, and this is the demolition. And in Denver, it is a precise science. Essentially, your demolition plan manifests itself in real life. You got to leave behind like 40% of the exterior walls in order to like grandfather in some of the benefits like an attached garage. It's just as stringent when it comes to the construction side of things. So we had this massive concrete wall that was kind of the centerpiece of the whole thing. And I was very concerned about the height of it because I can't imagine what it would take to, peel 6 inches of this thing off just to meet the zoning code. So you got to be really informed on what you're building, and I found that I wasn't quite as informed as I'd like to be. I'd build my floor heights, 10-foot floor heights and 1 foot for the floor system, but I reached out to John Brock because I was concerned about meeting, ducking under that bulk plane. And so that's really where all this started. Is he really helped me dial in realistic dimensions rather than my rough designer dimensions. And this project was truly a success. I mean, it came out great. So this is the final product, and I thought we'd just take a quick peek inside before I dig in on all the technical stuff. So this is right when you walk in the front door or living room, and that you can see that concrete literally from like every room in here, and pool in the backyard, and this is our dining room. And then up above we have this loft hammock, and that truly is the gem of the project. When you're up there laying on the loft hammock, you can see like every space downstairs. So in order to get here though, we had to navigate Denver's zoning code. This is for the urban house form. In the front 65% of the lot, we can go up 30 feet. And then on the sides, we come up 17 feet and then slope in at 45 degrees. So the front setback is what we call a block sensitive setback. Essentially, we just have to line up with all the other houses on the street. And then the side setbacks are going to be 5 feet. Now, this is a lot to take in. It's really just not very visual when you're highlighting these on the code sheet. So what I like to do is to draft this up and build these rules in SketchUp so that I can visually know that I'm ducking under that bulk plane. So let's hop into SketchUp and take a look at that. Okay, so inside of SketchUp, the first thing that we'll do is take a look at this site. I pulled all this in from Placemaker, all the topography, the aerial imagery. I use Placemaker to pull that in, and really improves the clarity so you can actually see what's going on the site. So this outer context area, this is not modeled at quite as much detail as this area here. This is my actual site with the lot lines draped on, and then you can see that I modeled this very precisely based on our survey. So let's get our survey in here. I'm going to go to this next scene here. This is the level 1 existing finished floor height, and that will be what we build off of since this is technically a renovation. But let's get our survey in here. I'm going to go to File, Import, and you'll notice that I do have the ability to pull in PDF vector graphics. What's that all about, John?
PDF importer lets you bring in vector PDFs so you can actually read all the text and all that kind of stuff instead of just being lines like you get in a CAD file.
Nice. All right, well then we're going to crop this out like this. I use this to on every project to bring in the survey for sure. And then I also use it when I'm making like sketch plans in layout to get those into SketchUp as well. So this survey is at a scale of 1 inch equals 10 feet. And so we're going to set that 1 inch equals 10 feet down here. And that way when I import the PDF, will come in at a real world scale.
You can
like
thank Mike Brightman for that scale feature, because that's why we added it after much harassment.
Yeah, I mean it's the little things. There's nothing bigger, to be able to skip the whole tape measure tool and scaling it and all that. So definitely a nice improvement, man. All right, so let's do that. So we get it kind of lined up, and I'm just checking my property corners here, and that looks pretty good. All right, so where we're at now is we have our level 1 existing finished floor. We have our survey pulled in, aligned at that at that elevation. And so now what we need to do is start constructing our bulk plane. So I'm going to hide this for just a moment, and let's talk about the bulk plane. So we were looking at this code sheet. We're working with like the front 65% of the lot. Well, a good way to get that without having to do a lot of math is to throw a guideline back here and then scale this kind of these lot lines to 0.65 like that. And then I could make a copy of this to the back like that, and then use my scale tool like that. All right, so now we've like struck the back 65%. Now, as far as the front setback, we're going to need, it's that block sensitive setback, and we're not going to go through all that math. It's basically like line up with the other homes, the front facing, the furthest projecting face of the actual house, not the porch. So actually, I think it is, this line would probably be better, but doesn't matter. Okay, so now we're going to strike another guideline up by 30 feet like that. And then I'm going to draw a rectangle like this. We're going to hover on this, hold shift, and then snap to the end there. All right, then I'm going to paint this with texture like that, and we're going to use our push-pull tool and slide this all the way to the back. All right, so now we've defined our 30-foot height, and we've got our front setback, our rear, not setback, but that's kind of where we're allowed to build up to 30 feet in the back. I'm going to make this into a group and then double click in, and let's now set another guideline at 17 feet up like that. Again, I'm just pulling off of here, so we go up 30 feet, and then on the side interior lot lines we go up 17 feet and kick in at 45 degrees. So now we'll go with our protractor tool like this, and we're going to lock it on the green and go 45, and then we're going to lock it on here 45, use our line tool and strike that and strike that. Then with our push-pull tool, I should be able to just double click to get rid of those. Control E clears my guides, that's my shortcut. Control E clears those guides. And so now, we're looking at, we're close. So the last thing we need to do is drill in here and do a 5-foot interior, side interior lot line setback. And then I'll use my line tool, go up on the blue, use those inferences like that. I missed that one, that's okay. Push pull, double click, Control E, clear my guides. There's the rules that we're allowed to build in, but what we haven't done is defined the height, which is super important. So I'm going to open up another file here, and this was like from the project that I was, these are my notes for this project. And so you can see that there's this little equation you got to run where it's like kind of the average of these 2 points, which is 22.9 plus 22.6 divided by 2 is 22.75. The difference between the finished floor and where my base plane starts is 22.75, so let's go 1.15 down. So I'm going to move this straight down by 1.15 feet like that. Now we have our rules set in place, and so I'll go back here with our survey on there, And I'm going to double click in here, and I'll just hide these two pieces for now so that we can kind of work in here. And this is where I really brought in John for his expertise, is setting up these like finished floor heights. And let me show you how I would have done it, or how I did this project initially. I'm going to draw a rectangle at like 6 by 10 feet. And then, as I don't want to say a novice designer, but just a lazy designer or uninformed designer, I'd say like, oh yeah, we're going to go up, say 9 feet, and then it's going to be another, 12 inches for the floor system, and then do 9 feet, and then 12 inches like this, and then do another 9 feet like that. All right, and then you go look, and you're like, oh God, now I got to come up another, 8 inches? And let me scoot this over so that, we can really see it. So it's like, that was kind of how I approached this thing, where, on my first rip at it and setting up these finished floor heights. And so I'll just throw some another material on there as well, like bam, bam, and paint this top piece so that we can see, that's kind of like how I would have approached a project in the past. And it wouldn't be a big deal, like if you were just building a new house out in the country somewhere where they didn't care about building heights and all that, or not so much. But in Denver, man, they are strict. So what we're going to do now is I'm going to have John kind of talk me through how this wall would actually be constructed. What do you say, John?
Yeah. Well, first of all, you got a bottom plate.
Yep.
So your bottom plate's going to be 1.5 inches, right?
Yep. So we'll do 1.5.
Yep. You said it was 9-foot walls, right? So next after that, you've got studs for a 9-foot pre-cut. The 9-foot wall is actually 9 foot 1 1/8. It's not 9 feet. Okay, you're going to buy studs that are pre-cut to work out to be 9 foot 1 1/8. That's to allow for your ceiling and your finished floor to give you a 9-foot finished ceiling. So studs in a 9-foot wall are actually 104 and 5/8. So
104 and 5/8. So 104 space 5/8. And then what's next?
Double top plate. So another 1.5, another 1.5.
I'll just double click again. All right.
And that should yield you a 9 foot 1 1/8. If you want to measure yourself from top to bottom, that should be your standard wall height. Yeah.
So 9 foot 1 1/8.
Rock and roll.
Perfect. All right. What are we doing about our floor system here?
So in that case, I think your structural guy said 11 7/8 TJIs. So 11.875 for 11 7/8 members there.
11.75, like that?
No, 875. 11.875.
Ooh, 11.875. Enter.
Yeah.
Like that.
Yeah.
And then 3/4 floor sheathing.
3/4 subfloor. Yeah.
All right. And then we'll just kind of paint those so we're seeing how that stacks up. All right, now up to this wall, we'll go another 1.5, right?
104 and 5/8. Oh no, 1.5. Yeah, you're doing the bottom plate. Yes.
Yep. And then what's next? 104.
104 and 5/8.
Like that.
Yeah.
And then we'll do 1.5 and 1.5.
Correct.
And then, shoot, remind me again.
11.875 is 11 7/8. You get used to the fractions, yeah.
Yeah, 3/4, like that, and then we can just stack these guys again, and then I can probably get this one started 1.5, and then I forget, what do we say, like 8-foot ceilings up top?
So 8-foot ceilings, your studs are going to be 92 and 5/8 pre-cuts.
All right, well, and let's stick with, I think I said 9 feet, so let's do 104 and 5/8, and then, this is where. Yeah, so and then what, 1.5? Yeah, you're busted. And then, and what about let's just build this out and then we'll make our adjustments.
Sure.
Decide which floor we want to pull this
out of. So I think you were using LVLs that were 9.5, I think, on top of that.
Okay, so 9.5 and then another 0.75.
Yep.
Yeah, like that. All right. And, yep, that all looks good. All right, it all looks good except we're busting through our bulk plane. But at least now, we're like super confident about where we stand on this. So Probably, I know on this project we were okay with the top floor coming down like, say, 12 inches, something like that. And then I think we would probably pull this one down another 12. Is that accurate?
Yeah, so a 9, an 8, and an 8, and that gets you underneath that plane.
All right, and then where does that put us? Like, what is our overall dimension here, or our leftover wiggle room? So we got like 7 inches. All right, and then I do remember on this project, it's been 2 years, well, more than that since I was messing with these drawings, but we had like a curb as well going around that, and it felt much safer to give ourselves a little bit of breathing room and really know that was the case. So, So that is kind of the difference between just throwing in the designer finished floor heights versus, really dialing in exactly how this would be built. But, also like, there's nothing wrong, right, with like some weird dimension. Like, John, what if I wanted to make this, like 3 inches higher? Like, no big deal, right? But it just gives the guys in the field a lot more work. Is that true?
Well, you're gonna have to you're gonna be cutting studs one by one. Mm-hmm. Every stud would have to be cut if you go with a custom height, because you can get 8 foot, 9 foot, and 10 foot pre-cuts typically in most markets, I think.
Yeah.
Now, when you're on a concrete, if you're on a concrete slab, you would have to cut those studs anyways, because it's rare that your floor is going to be perfectly level. So you'll end up having to cut a little bit off of each one potentially, unless you're in a level straight. So.
Gotcha.
But yeah.
Cool. Okay, the last part of this then would be to set our floor heights. So that's kind of what I was getting at, is that, we have all these plans pulled in. And so now, instead of just throwing them at, these kind of rough floor heights, we can set them at very precise floor heights.
Absolutely. We like precision.
You like precision, yeah. Me too. Especially on this project where, just ducking under that bulk plane really had me nervous all the way up until we got that final approval. So, okay, John, I think I'm going to pass it over to you to take a lap through some slides and talk about some other issues in line with this. Like, this is just like one area where, we can bridge this gap between the design and the construction and the reality. So I'll hand it over to you to walk through those slides.
Well, first of all, it's a killer house, man. I'm very impressed.
Thanks, man.
Seriously, as a builder, I would love to build it, and as a 3D guy, I would love to model it. So
yeah, nice, man.
You did a killer job on that. So all right, well, let me. I'll go ahead and share my screen, and we'll pull up the presentation. I'm going to give you a little bit of builder's insight on my take on a few things here. So one of the things that kind of drives me crazy is architects often use 4-inch and 6-inch lines or spaces for their interior walls instead of 3.5 and 5.5. I don't know why, other than it's simpler to offset 4 and offset 6. Now, we do 6 for our exterior walls because that includes sheathing. But you can imagine how it can lead to a lot of layout nightmares and mistakes. Like, you can see the string of dimensions that are running across through there. A carpenter out in the field is going to be the one that's going, okay, I'm going to go 1/2 inch this way or 1/2 inch that way. What if you had a prefab tub or shower, say a 60-inch prefab tub? Well, what if that space that is 60 inches and it has to go in after framing? What if it's 59.5 or 59 or 60.5 or 61? To me, it just builds in errors that can happen and head scratching. So that's kind of one of my little pet peeves. I'll throw Dwayne Addy under the bus. He's helping me on this one particular job. So I always tell him to think about the framers and think about framing. And I've told him forever I want 4.5 inches, then a rough opening for a door, which is a door size like this 2.8 door plus 2 inches is 2.10, and then another 4.5. Okay, that would give me 3'7", not 3'5". If I hadn't caught that, the guys would have framed it. They would have used 2 2x4s on one side, 2 2x4s on the other side, and then they would have to rip a 1/2 inch piece of plywood both sides to close that in. Now, the purpose for the 4.5, you can do it with 3 in a lot of cases, but most of our projects we use a wide casing or even a 2-piece casing. And I can't stand to see ripped casing. It just drives me nuts. So So he went back and corrected that, but that's sort of my workflow of laying out things with dimensions. Now this is a house that was an awesome house, awesome designer, 50-some pages of drawings. He had every single thing detailed, but he had some things in there that I didn't really agree with, right? So I'm looking at it. This is actually a snapshot from our virtual tour, because I took his plans and built a full SketchUp model in a virtual tour in Inkscape, okay, with a picture of that background that you're seeing of the lake. So I first said, hey, this door is kind of slammed up against the wall, and I'm going to have to rip the casing. He said, oh, I know we do that. That's fine. Well, not fine with me, but I went along, right? And then you can see the window to the left, and there was another stairwell on the other end of the house where there's a window being blocked by the stairs, or right adjacent to it, or behind it. And so that leads some complications of how do you get in there and paint? How do you use this? And you can see it from the outside, right? So I just remember the expression, it was a signature feature. And I just remember thinking, yee, you know, beautiful house though. I mean, I love the designer, I love the design, and it came out beautiful, but these are kind of little pet peeves. Same house, we go upstairs on the upper level where we have a sloped ceiling, and I'm going, the casing's going to have to be, you know, cut right in there, you know, and it's going to look like crap. And I said, let me show you. And I did the virtual tour, and they went, oh, that's fine. And I was like, yeah, it's okay with you, but it's not with me, because what if one of my other customer comes through, another person, a prospective customer comes in and goes, wow, you know, or somebody visiting the house and goes, well, who built your house? You know, I think it's a reflection on the builder. So it's kind of that, let's have some discussions on some of these things from a design standpoint. Here's another Dwayne Addy one. Love him to death, but he puts all these brackets and gables everywhere, Dwayne. So here's what we actually did, but so
they look cool, dude. They look cool, yeah, man.
They do, but what happens is the architect gets to design the Taj Mahal, and then the builder gets to be the messenger to say, you can't afford this, or they're going, $2 million, what? So in this case, there were 7 of those brackets that were $660 each, of those gable pediments, whatever you want to call them. You're an architect, call it whatever you want to call it. And then these corbels or brackets, there were 6 of those at $250 around the house. I mean, that's $6K, $6,000. That a lot of times falls by the wayside on the budget acts, right? That happens a lot. In this case, we went ahead and did it. So anyway, it's just one of those things that point out that even like metal roofs or things like that, be cautious of what you're adding, because the client may not know. They don't know any difference. They don't know that these things cost $660 each. They don't know that a metal roof is 8x the price of a shingled roof, or 5x or 10, whatever it is. Point is, it could be $60,000, $70,000 more. So if they're looking at a set of drawings of that metal roof, and then I go, well, that's $60K. Oh no, we want shingles. Then we're back to changing it out. Now this is a house that, you know, how a SketchUp model got me $1 million job, right? So I got the set of plans from this guy, and I'm looking at it. I'm going, what's this dashed line in the garage? It's a cathedral ceiling in the garage. Why does he want that? So I reached out to him and I said, you know, what's with the cathedral ceiling in the garage? He goes, oh, I'm a car guy. I want a car lift in there. I've got 2 sports cars. I want to park one under the other and raise the other one up. And I'm going, yeah, that's not going to work. So all I did is popped into SketchUp. I modeled a couple framed walls. I mocked up the exact scissors truss that was featured in there, and showed him that the cars would be banging into the ceiling, right? But I said, you know, before his blood got boiling, I said, but let me show you how we can fix that. So we came in and did the same roof pitch, but I used 2x8 rafters. I used, without having the scissors pitch. A scissors is where the top chord is different from the bottom chord. And that's how you can achieve a cathedral ceiling and still structurally do a truss. The problem with that is a lot of people will do windows. I built on a lake community, and there's a lot of these gables, and then there's scissor trusses, so the pitch of the windows is half of the pitch of the roof, and it just looks horrible. So in this case, we used 2x8 rafters, ceiling joists in there to get the headroom that he needed. We actually took this funny looking dormer that wasn't centered or anything, and he wanted to have a center bay on a lift that he could actually work on cars. So he had 2 car lifts. And so we moved that dormer to the center and gave him that full height headroom. That's full height front to back, or front to the back slope. So anyways, cool way. He was super happy, but he would have been super unhappy had he gone with another builder. Here's a common thing, is stair headroom issues at stairs. Very common, where people aren't doing a 3D model and detecting clashes like this. So when we first did this and we put this 18-inch trusses in there, you're banging your head right here. So before we got any further than that, we do constructability where we get the trusses and we actually bring them in to make sure that they work before we order them. So I knew that we were going to need to use a 2x8 floor system right there to get our headroom. So that's what we ended up doing. So again, these are issues that may not get thought of in the design phase, which should, but not everybody sees these, especially if you're doing all 2D drawings and not 3D models. You know, if you're building 3D models like Mike, you're going to see these kind of things in front of you. Here's one where the stairs were specified out to be 17 risers, but it's kind of one of those cases like you were saying, Mike, where you see how they've got 9 foot, and whatever arbitrary numbers using. When you use what was actually specified by the structural engineer using these 14-inch LVLs, that bumped up that headroom enough to where it needed one more riser. So 17 risers is only 8 inches. By code, can't go more than 7 3/4. So that meant 18 risers. And what would happen as a builder, I can tell you right now, this structural members, these would have all been installed per this plan. And you'd have this doubled up LVL, doubled up LVL, doubled up LVL, doubled up LVL. Then you would have gone to build the stairs and realized, well, I can't put another tread here because it's blocked by this door. So I got to go this way. Well, that means you'd end up having to tear out basically all of this because you can't extend these LVLs. So it would have been a nightmare, you know, had we not caught this by doing a 3D model. Here's a constructability job we did for a 6-story building in Alberta, where the MEP guys use the architect's plans and to model all the plumbing, right? So we have plumbing stacks, water lines, gas lines, all kinds of stuff coming up through. Well, in this case, they designed where this unit on the above has a load-bearing wall there where the plumbing wall is. Well, the unit below, there's no wall. So the structural engineer just sticks a big I-beam in there, right? Well, the MEP guys have these water pipes coming up through, drains coming up through, toilets coming up through, another one coming up through, and they don't catch that. So you've got 3 different players here that aren't collaborating and talking to one another. So, I mean, again, that's a huge gap that needs to be bridged in our industry. A lot of times architects don't think about the HVAC returns that are going in the house, right? They almost invariably will take up, unless they're pre-designed in, which is kind of hard to do, they will take up part of a closet, right? In this case, we actually had 2 return airs. One took up part of a closet in here, and one we actually had to build a chase just for it. And we also do all this before we order, while we're doing these trusses, we use that truss layout to determine, and that helps us to shift those trusses if we need to give access. So what we were able to do is show the client, hey, you're going to have a return air in this hallway here and one over in here. Well, I don't want that. Well, you have to have it, and here's why. Okay. So I think it would be nice if architects maybe collaborated with some HVAC guy or maybe with the builder if they could, or at least be aware that a return air register is going to have to be involved somewhere. And I can tell you now, the clients don't like them. They don't like looking at them. But if you explain up in front and you manage their expectations, it goes a long way. Here's where a 2D roof plan, they never did anything in 3D, obviously. Everything looked great on the 2D roof plan. You know, this gable lined up right with this ridge, everything looked perfect in 2. But the reality is that was a 16-inch or 18-inch overhang there, so you've got a wall that's set back there and nowhere to deal with this water coming out of here. So the builder would have to rig up some sort of a cricket to get that water out of there. Again, things just aren't visible on a 2D drawing. I often see where 2 levels don't align. So one of the things that we do, we use that PDF importer tool that Mike was talking about. We import our floor plans, and then we would do a story pole using SketchUp's guide points, or guide points, where we go from, just like he was doing by building that wall level, we actually build that out of guide points and make that into a group of guide points, which I actually lock. So my erase guides is actually a script called locked guide saver. So I use Control G, I think Mike was the E, and when I do that, it deletes all the guides except for what was locked in, because I want my story pole to be locked in there. But what we'll do is we'll then move one floor plan over to a line, snap in a line with a common corner, and this is where we catch these mistakes. Here was 10 foot 11 on this upper drawing and 10 foot 9 on the lower drawing, right? So I knew this in advance. When I modeled it, I was able to determine which was correct and make that adjustment to the field set of drawings before it was built. So one way we can bridge the gap is with tools like SketchUp, Inkscape, and 360 cameras. So I'll show you how that works through. We create realistic virtual tours in SketchUp or using our SketchUp models, but we do it in Inkscape. So I'll show you what that looks like. All right, so this is a virtual tour that we put together for a house that we built this year. Obviously this was done before we built. So before we start the house, I take out an Insta360 1X, was that X1? What is it, Mike? You got one of those?
Yeah. I got the, I forget what I have. I have the X3. So.
Gotcha, because I have whatever one I have, but I bought years ago. And so what I do is I go out and I'll capture the full 360 by 180 shot like you're seeing here. Now I'll go out onto the deck of this house. Now the client here, this is Smith Mountain Lake Dam in Roanoke, or excuse me, Smith Mountain Lake, Virginia, outside of Roanoke where I live. And they wanted to be looking at the dam. All right, so we literally put a stake in the ground. My guy, we have an RPT 600, a Trimble unit that we use to stake out our houses and to shoot our topography. And we literally set 2 stakes in the ground pointing directly at the dam. We shot those 2 stakes, we came back to the office, and then we aligned the site with that view. So that's why they're looking directly at that view. So we're able to, in Inkscape, take that 360 image and rotate it until we're seeing what we want to see. So the cool thing is here, no matter what you look out of, whatever window, you're looking at the actual view, which is pretty awesome. Now this is a house.
John, you actually used Enscape to create what we're seeing right now?
Yes, this was all, yeah. So what we'll do is we have a scene in our model, in our SketchUp model, we use, it's kind of the quick little trick we do is we find the center of the room and we place camera at 5'6", head eye height basically, and we create a scene that positions the camera right in the center point of the room, and then we have that for each room, okay? Then we batch render. Mason will leave for the day, and he'll batch render in Inkscape and come back and have all these equirectangular JPEGs that we use for these tours. Then this is then processed inside of, right now we're using a service called Cloud Pano, and that allows us to upload all these and then to add all these hotspots. So you're seeing the hotspots you have in here. It's kind of like the Matterport thing, but so we do as much realism as we can. You can see Mason even puts the thermostats on the wall. Shut up, Mike. We do electrical outlets and switches. Now this is one of those things where the designer, this is a little spill in the beans here, but see this 1x12 baseboard that got used in here? It was originally 1x6, and anytime I go to 1x8, 1x10, or even 1x12, which I wouldn't do 1x12 in a 9-foot ceiling, it's just a little too much. I definitely do 1x8s. Anytime I go past a 1x6 though, we rotate the outlets and put them an extra, so we got a bottom plate, we'll add another 2x4 block just to space it up, and then we put them horizontally so that your outlets are actually in the baseboard. So I wasn't aware of this until after we had already roughed in the house and drywalled, so I could not change that. So that was kind of a little pet peeve. But so the kitchen turned out okay. It wasn't too crazy, tile wasn't too crazy of a selection, and we get these things looking, as accurately as possible. My guy Mason in the office will model the plumbing fixtures and lighting fixtures to the best of his ability, sometimes spending too much time on them. But one of the things that we had as a designer, I'm going into this green laundry room. Yeah, folks, that is what it looks like today. So when we did the virtual tour, we thought, well, they'll see it and they'll hate it, but that's what the interior designer selected. But no, they loved it. It originally had green walls too, like a different green. And then this clashy green right here, this is like exactly what you see in real life, and they love it. So as long as they love it, that's cool. And it also had some crazy wallpaper, so we pop upstairs. Sorry, this is fun. So we actually have floor plans too, so you can navigate. Floor plans you could also navigate with thumbnails, which is kind of cool. So if you go up into this, to their son's room, wow, green whatever wallpaper. So here's a picture of what it actually looked like. I'm going to actually exit full screen here for a second so I can pull up this image. Yeah, that's a photograph. Wow. Versus what he showed him. And yes, we love it. I'm going, man, I don't. And then the bathroom, check this one out. In the girls' bathroom, that's what we have. We have blue cabinets with this crazy wallpaper going on. So if I go into, I'm going to pop over into my tour here. Cool house though, man. Yeah. This was Dwayne Addy and I designed this one, so shout out to Dwayne. So yeah, there it is, man. Dwayne hasn't seen this yet, he's gonna puke, but yeah. Yeah, see how close that is. Even the colors, Mason did a great job of matching colors and all that stuff.
What about the outlet? Yeah, nailed it on the outlet.
Yeah.
Yeah.
Well, actually, ours has we have one that's got the GFI on there. You like that? Yeah. So Mike gives me complete hell over the detailed models that we do, but I mean that's part of the whole bridging the gap, right? I mean, this is the ultimate bridging of the gap where all the collaborators can be on the same page. So.
Well, but it also makes sense. I get it. Like, you know, and this is kind of a realization as we're working on this presentation that you are using your models for a different purpose. You're building off the plan, whereas I'm essentially making the plans from the model. You have the plan, and now you're plotting your attack at building this thing. So I kind of get it now. So although when you complain about it, I do think of the thermostats, and I think there's your problem, man. So.
Well, I will plug a free plugin that Trimble actually created called Material Resizer. And you may have told me about it, Mike, but I literally took some of our files that were 200 megabytes and reduced some of these crazy materials. Like Mason may pull in a hardwood flooring texture that looks cool. Well, that thing might be 3 megabytes alone. And so we've been drastically cutting down our file sizes by just using Material Resizer, just that one simple tool. So jot that one down.
All right, so up next we're going to take a look at one of John's, it's a bathroom model. It's a portion of a house here. And we're going to send it over into layout to create some floor plans. And kind of like I mentioned, you know, John builds or designs the plan in 2D and then kind of uses Framer and builds these really detailed models for a different purpose. You know, I'm kind of used to building the 3D model that nets the plans, and he takes it from a different direction for a different reason. But it doesn't mean that we can't get a floor plan from this model. So right out of the box on a fresh install, our Conduct Tools extension automates plan sections, elevations, and perspectives based on whatever tags are visible. So I want to turn off all of these tags except for our floor plan and our dashed lines. So I'll just turn those off. So basically I just need to manage my tags manually, and then I'll hit the plan generator, and we're going to create a color floor plan. I'll click create plan, and then that's going to set the camera view to be overhead, picks a style, it names my scene, and gets it all sorted out like that. I'll hit reset. The reset button always kind of bounces you back out to kind of a lightweight working area here. I'm going to update my design scene so it doesn't have that active section plane there. And let me look at this. Scenes, design, active section plane. We're good. All right, the other thing I want to do is snapshot some interior elevations. So I could kind of get down into this bathroom and then activate the elevation tool and click on that wall. And for this one, I'm going to do a color interior elevation. And then it'll bring me back to that same view, like that. And then we'll go to this wall and do a color interior elevation, like that. And we'll spin around just a little bit further, like that. And we'll snapshot a view over here. So color interior elevation. So that's just created our scenes here. What I typically like to do is kind of work through. I know that I want to work on this area of the plan, so I'm going to update that scene so that it's a little bit easier to get there once we're in layout. And then same thing with these. I always kind of go take a look at all of my drawings in SketchUp before I send them over into layout, just to so I don't have to do so much cropping over there, like that. And then over here.
Dude, do you know how much time that saves what you're doing right now?
What's that? The updating the scenes or the elevation tool snapshots? So
just those snapshots are amazing.
Oh yeah, man. I think I made a video a long time ago. Like, you know, it takes the 12 steps that are saved between, you know, adding the section plane and like, oh, here, this is a good example here actually. Now that you bring it up, we add a section plane, pick a style. Name the scene. You can see that we named these 1, 2, and 3. With the full like Condoc Interiors or Architect, you know, if you load those drawing sets, these guys have all the tags baked in. But I just thought we'd use Flex because that's kind of an easy one to work with. This is a good opportunity to show a new tool that is actually free on the extension warehouse, and it's also part of our new release, Condoc 5.3. So we have two new tools: isolate active section planes and purge unused section planes. So for instance, like on this drawing right here, like we're slicing through the bathtub, and maybe that's not ideal. So I need to get to that active section plane. So I could go to view and turn on section planes, and then, you know, select this section plane and then scoot it around. But what happens is you often end up with a lot of section planes. It can be hard to dig through these. So we have this new tool, isolate active section plane, and that just hides all of the other, turns on section plane visibility and then hides all the inactive section planes. So it makes it really easy to, like, you know, scoot this back, and then I can go check that. So that looks a little bit better. I'm getting a better view. So
that's awesome.
Yeah, and then here's the other one is purge unused. This one might not have any. It doesn't have any unused section planes. But, you know, if you just had like a rogue, you know, throw like a section plane in there, like this, and then go back to the scene. Well, any section plane that is not attached to a scene is going to get deleted. So you can see there's one like that. All right, so that's how our Condoc Tools works with the Flex drawing set, and then we can send these out to layout, and we can get back to talking about kind of this bridging the gap between design and reality. So let's hop over into layout. So inside of layout, I'm going to start a new document, and we're going to go with our templates will be a 24 by 36. Start like that, and then I'll just double check in SketchUp that just finished exporting, so then we can go to our Condoc drawings. So whenever you export out of SketchUp, they always land in your Condoc drawings scrapbook, and we've, you know, set the scale, you know, not so much on Flex where we optimize line weights, but we've definitely optimized the render settings, you know, for the different types of drawings. So here's interior elevation, and we'll scoot that in. And it is kind of cool, like, I guess the layout API doesn't have ambient occlusion included in it, but once I render this thing, it should kind of dial up that style like that. So we just stretch these around and, you know, crop a few like that. And let's build this set real quick. Like that. Bring in these other guys, and then go to the next, like that. All right.
It's going to take me a half an hour. My
man.
old way.
The old way, right? Yeah, I mean, I get it too. You know, like if you're working with templates and all that, that can be handy. But I just find that, like, the reason you know, it's funny. We all have the same story. Like, we build these plugins because we need them. And then you're like, oh man, I could, you know, sell this. Other people need these too. But, you know, it's like I kind of,
they're born out of necessity.
Yeah, that's it, man. It's like I was working with templates, and I found that, like, no matter how clever my template was, it didn't address, you know, all the scenarios. It was better to have the flexibility. I'll just go back to my Condoc annotations like this, and this is another scrapbook that gets installed, and so we can just throw down like some drawing titles. And then you can throw like some, you know, interior elevation callouts wherever you want them, and room names and all that. So, you know, we really just kind of like, when you install Condoc Tools in SketchUp, you get everything you need all in one, like all the title blocks, templates, annotations, all that. But point of this now is that we've got like a floor plan here, and I thought we'd like walk through with John, like, what are the critical dimensions to call out here. So yeah, can you help me? I'll just, as you talk through them, I'm going to sample the half-inch scale, and then, yeah, just talk me through some critical dimensions on this plan, if you would.
Yeah, so in this case, there's the minimum required openings that we have drove the design here and drove the floor plan. That's why it was important. These dimensions are crucial that a lot of people don't know about. So by code, I have to have a minimum 34-inch opening. Once I get through the front door, I've got to get to a bedroom and a bathroom with minimum 34-inch openings, right? So that's a code issue. And so that first one, I made it a 3/6 cased opening, right? So the rough opening for a cased opening is 3'2", or excuse me, rough opening for a 3/0 opening is you add 2 inches to the size of the door. What that's doing is giving you 3/4 of an inch plus a shim space on both sides. Okay, that's what the 2 inches extra is for. And again, like I mentioned earlier, I like to go 4.5 and 4.5. So that makes a hallway 3'11". It's not 4 foot, it's not 3'10", it's 3'11". So that's why you're going to see that dimensionally being 3'11", right? So then we have our wall defined that separates our great room from the master bedroom. So that's where I go the 4.5 to give me room for the casing that I have, the 3'2" for my rough opening for a door. Now I can't use a 2'10" door, even though 34 inches is 2'10". A door will have stops on it. So I'm limited to, that would give me 33 inches clear. So I have to go to the 36-inch door. So that drove those dimensions, the 4.5, then the 3'2", and then the 4.5. That defined that hallway right there, right? So that's where that came from for the dimension that you're going to see there. Okay, that defined that wall that develops or generates that hallway. So then if you went into that hallway that's going to the bathroom, it's back to that same principle. I've got, now in this case, same case, I got a 3/0 door that's going into the bathroom. So I've got the same 3'11" hallway. And that's what defined the closet to the left, right? So then you'll see down the pocket door that goes into that closet to the right. That's where I actually did cheat my rule of the 4.5 inches. I went 3 inches, which is 2 2x, on that side of the pocket door because I wanted to give a little bit more room for hanging clothes, right? So it's kind of tight as it is, so that extra 1.5 inches helps. And if the casing is, I don't want it to be ripped, but if it's tight against that inside of a closet, that doesn't bother me visually. Sometimes it's literally just tight to it and that's fine, or maybe they have to rip a tad off of it. So breaking the rule right there, okay. So then we're going into the bathroom itself, and you'll see that we've got a toilet room, all right. We've got to get into that toilet with the same 34-inch opening, and width for the toilet, I like to use 3 feet clear, drywall to drywall. So that means 3'1". So there should be a 3'1" dimension on that toilet back wall of the toilet. Right. There you go. All right. Now, this was a case where the wall to the right there was generated by that hallway to get to the bathroom. The wall to the left is locked in with an exterior wall. And I've got to get a door that will pass code to get into that toilet room. So what I did here is a pocket door frame, or a pocket door opening, you'll see it's got a 2'10" door without any stops on it. That gives me my 34 inches, right? But I have to work from the left side because a pocket door frame, a rough opening for a pocket door, is 2 times the width of the door plus 1 inch. So that would be 34 times 2 is 68 plus 1. So when I did 69 inches, I can go right to the interior portion of that exterior wall. The pocket door can go all the way back to that framing and it's fine. But when I did 69 inches going the other direction, that left me only 4 inches on that jamb side to the right. So I broke my rule, but 4 inches is fine. They'll do 2 2x and they'll rip a plywood or something like that in there for just that one case. So that
can't win them all, right?
Can't win them all. Made it fit code right there. So
that's right.
I guess other dimensions would be, making sure that that you've got clearance from the bathtub that's there, the soaking tub. You don't want it too tight to the vanities. I mean, these are architectural things that you guys have a great sense for spatial needs with those kind of things. That's not like the technical stuff I'm getting into with being picky about dimensions. I guess one other thing I note too is that shower is actually a curbless shower. I mean, it may look like from the drawings, but the client wanted it to be a curbless shower. So it's a good thing to note or to ask your clients, because if no note's on there, like if you didn't ask them, and then the floor system gets stuck in, then you can't do curbless. If we builders know about that in advance, then we would be able to notch the floor down, or actually, in some cases, we'll do that within the trusses. That will allow us to recess it down. All we need is that 1.5 inches, and we can work with that. We can actually work with 3/4. In fact, we've had jobs where that was overlooked or decided later, and we literally cut the subfloor out where the shower goes and dropped blocking down 3.5 inches or 3/4 of an inch. And then put nailers in there, and then we put little strips of plywood in there, so the top of the, you'd have the top of the truss, top of the sheathing, top of the truss, top of the sheathing, so it lined up. And we were able to still do the shower that way. But again, these are just kind of little, I consider this bridging the gap because we don't want code issues, right?
Right.
Plenty of times you got we don't want these issues, and you as an architect don't want a client or a builder calling you up going, hey man, what you drew didn't pass code and blah blah. We could probably all feel that little tinge of pit in the stomach of those conversations. So by doing these kind of rules, I think it helps to, again, to bridge that gap.
Yeah, well, it's a balance, right? It's like, there's rules. I mean, it's just like, what I was showing with Denver, just go build it super tall or whatever. It's like, no, there's what looks good and there's what's allowed, and we got to find that, the in-between there that's pleasing every angle of this thing. So it's cool.
Exactly right. Yeah,
nice. Right on. Well, then we're going to start wrapping things up with a look at Spot, like your new extension that, again, bridging the gap between the builder and the interior designer, or designers in general, but in this case, tracking selections. And so you're going to show us your screen on that one?
Sure. This is that same model, right? But so in this session, description mentions enhanced collaboration and streamlined workflows, right? And so I think SketchUp, along with extensions, is the best way to achieve these goals. So Mike, your Condoc tool certainly allows your users to streamline their workflow. What you did was amazing how fast that was put together. So we recently developed Spot for SketchUp, right? That allows us to streamline our workflow with tracking all the selections and products that go into a house. So it helps us to collaborate with all the stakeholders. All right, so Spot allows us to document, estimate, and track all the products and even labor and the selections in our projects. So I'll show you what that looks like. This is Spot right here. Cool little logo that I actually created using SketchUp, which was kind of neat. All right, so in Spot you add levels and spaces. Now I call it spaces because a deck could be, it's a space you need to track the decking, the railings, things like that, but you wouldn't call it a room. So that allows to do porches and other things in there. So you do the levels and then you can add spaces. We won't get into anything more past that. I've only added this one room in here, okay, for right now, this master bedroom. So you can see in here that there's 18 items that are currently needing to be selected. There's actually 2 more that I'm going to show you that I had overlooked. So I'm going to show you how we can dial those in. But the cool power is this traffic light dashboard, right? So it allows us to see, well, what's not been selected, what has been selected but not ordered, and then it's received and installed. Now these 2 are the ones that the field guys are going to be keeping up with, right? So what it does is it comes in with this nice, we have a room view here, which is basically a visual storyboard of each item and its thumbnail image. Now the thumbnail image that you're seeing here, these are SketchUp thumbnail images of the components in my model, right? So the idea is we start out with, it's basically a placeholder. Like you can see bath faucet TBD, to be determined. We've got 2 of them, they're identical. There's one left and right of these vanities, so we have a quantity of 2. In my database, in my items database, I've got a generic bath faucet that's $300, right? Plus our tax, that sort of thing. The idea is that once the client picks out the one they want, you could change the status to selected, or you could update it in here, change the status to, from neat selection to selected. You could then put the description in there, what's the name of it, what's the brand, what's the model number, what's the color. You could put all that information in, put a date for when that was made, put the actual price in here. You could actually break the link to our database right here and change the price so it doesn't change back to what you have in your database. So it's pretty powerful, and then your final image here will be the actual image from the website for the product, right? So you can see it's also organized by cost codes. So we have a category view. This is basically your estimate view, and it's done by cost codes. Now you don't have to use cost codes, but it's a great way to organize your models, right? Or organize all these things. Otherwise it'd just be alphabetical order. You might have a chair next to a dishwasher next to a faucet. It wouldn't make a lot of sense. And also with each room we have a storyboard feature that will auto-generate a storyboard for you. It'll automatically create a PDF that fits several to a page. I can pop one up here. Let's see what that looks like. bring it over here in Bluebeam that I had over another screen. So you can see how it created this storyboard automatically, right? I didn't do anything but click that button.
That's
and
awesome.
It'll have the need selection. Now we're going to work on a way of customizing this, because I know a lot of interior designers want to customize their storyboards, but I didn't have to go into any other software. I didn't have to go out to layout. I didn't have to do any of that, right? It's automatically generated.
What's that QR code all about?
The QR code is meant to, it doesn't work right now, it's a
Yeah.
placeholder, but the idea is that you could have that posted out on the job site and then scan that QR code to learn more about that, that product.
Nice.
So, or you could have it out, you could have it in the plans and you could scan it. You would always be getting whatever's on your server, so it's the most recent data. You don't want anything that's outdated, because this stuff, trust me as a builder, these things will change constantly. Clients will change, they'll change them.
The idea is that Spot is single point of truth.
Single point of truth. That's what SPOT stands for. Thank you, Mike.
Yeah.
We do have we're developing a SaaS platform that does this very thing you're seeing here. It doesn't rely on SketchUp. It's SketchUp, the accompanying plugin. So this is how we can really get our takeoffs, which is hugely important. We can get full estimates done in here. So let me show you how that's done real quick. So you can see all the different items we have in here. We have plumbing fixtures, lighting fixtures, paint color, right? This is where you would actually put in whatever your Sherwin-Williams 7362, name of the paint, whatever that is. You could also grab quantities by collecting areas. We have vanities, we have the granite countertops. Again, you'd put the actual one that you want to use in there. Shower drain, bath. We have bath floor tile. We have the shower floor tile that you see here, and I forgot to do the shower walls, which I'll show you how to do here in a second. Mirrors, these are custom mirrors. I can just simply collect those spaces and instantly pops out. I've got 37 square feet of tile of mirrors. And then my bath hardware, right? And then a shower door. We got the shower door that has to be accounted for. So that's a ton of stuff. But let me go ahead and show you how this works as far as adding a new item. I'm going to zoom up. I forgot to do this little tub faucet. So I'm going to select it. Yeah.
A quick question from a technical standpoint. Like, do they work with groups, or is it only components that you're pricing?
It works with groups. It works with groups.
Nice. Okay.
Yep. Even nested groups, right?
Yeah.
So I'm just going to select it, then I can come over here and click plus selection item here, and you'll see it automatically pulled up the thumbnail image. I could rotate here a little bit and then say current view, and it'll give me a different view of it. I can do 2D front view if you wanted something more simplistic. But I mean, again, it doesn't really matter. This is a placeholder until you've picked out the final product. All right. Yeah. And so actually, I had entered this one before, so it already pulled up all the information that it had in here. So we're up to 19 items right now. So let me show you how to get this shower wall tile in here. So let's come over here into, we're going to be off of selections. You want to be on a certain, if you're selected on the SketchUp object, it's going to import that one. So I'm going to say add selection item. I'm going to come in here and type in master, well, just shower wall tile. And for right now, the description, I'm just going to put wall tile TBD, because we don't know what it is yet. It's in the master bathroom. I'm going to come over here to tile, and here's my tile materials. And now it's going to look into my item codes. I have shower walls in my item codes in here. So you automatically pulled up the $6 a square foot, but now I got to get my quantity, right? So I've got this cool picker tool, and I'm going to choose, I got length, area, or volume. I'm going to choose length, and all I have to do is hover over a face, click. That's 55 square feet, click. Now we're up to 84, click.
Yeah.
Just simply clicking on these faces, and I'm calculating as I go, or I'm accumulating all these areas as I go, right? So
you know what I like better about that? I mean, your estimator tool's killer, but like it was estimating based on the material, and if you accidentally painted something or the backside, I like this picker tool where it's awesome. Yeah. Again, visually,
and you notice it also. Do you see how it pulled up the thumbnail image too?
Yeah.
Automatically, now it's kind of a grainy image, but so then I just add that item, and now I'm up to the 20 items, and then I can print out my storyboard and go from there. So that's how we're tracking all of our products and selections. I failed to mention too, one little quick add is it's not just a once and done. So I could come over here to this tile that we just added. I can edit that and click this little plus button here. Let's say I wanted to add material or labor for that. So I could come in and say tile and choose tile labor, and then choose from there. I have a tile labor per square foot for shower walls, and that's going to use that same quantity. It's going to come over here and update it. So now when I go back over to category view and I pop over to my tiles, you can see I've got my labor in there as well. So it's a pretty cool
Wow.
trick.
Yeah, man.
Even the shower drain that we have in there. So
Yeah.
that way, because all these things, when the guy's out in the field and this stuff is delivered, they need to know what to expect, right? They could have a manifest, or sometimes you'll have something on back order, and so this way you could say, okay, one of them was received, one of them was not. So it's just a good way of tracking all the products, and then the guys in the field have a visual of that too. They'll see that thumbnail image and they'll say, hey, this is a chrome faucet. It was supposed to be oil rub bronze, And these mistakes happen on a daily basis in the construction industry. So we're on a mission to try to eliminate those.
To bridge the gap.
Exactly.
That's
to
it,
bridge
man.
the gap.
That's right.
Exactly.
Well, I think, yeah, you've done it with this. This is like, I'm kind of imagining how a SketchUp model can be handed off, really flexible too. Like if an interior designer was working on this and then handed it over to a builder who's using Spot, like it'd be so easy to just whip their model into shape,
Right,
Oh,
and they could
from
even
a
add
builder standpoint.
all these trim pieces that you're seeing in there. We could have a length tool. We could collect all these pieces of 1x4,
Yeah.
1x4 casing, 5/4 by 6 head casing. All that stuff can be done using the picker tool just by clicking on it. So, an estimator we do with Profile Builder, where we typically extrude everything with Profile Builder and then have that be on a tag, and then it'll report the lineal footage. But here, it doesn't matter how it was modeled, because a lot of people aren't going to model with Profile Builder or make it look as pretty as we do. They'll just maybe make it look like baseboard. And so this way we collect all those different attributes. As a builder, I could go in and collect all those from a designer's model and get interrogate it for all the information that I need to get my estimates, no matter how it looks.
Yeah. Nice.
Cool stuff.
Right on, man. And this is available coming soon, right?
Yes, sir. Hopefully by
Nice.
the time we hit Basecamp.
Awesome. Yeah, man. I mean, that was excellent. That was like, I think it's easy to see the importance of, the 3D models. And I think we all agree that like a 3D model is a great tool to communicate. And, hopefully this presentation illuminates how it can be used to communicate from the designer and to the client, to the builder, and, everyone, all the stakeholders in the project. Yeah, do you have any final thoughts on that, John?
No, I think it was great. I mean, it's fun to collaborate, and we each have our own expertise, right? So joining forces on something like that only makes the project that much better.
All right, well, cool, man. I'll see you in Vegas for Basecamp, and we'll do it again. So
Sounds great.
all
Thanks,
right,
Mike.
see you, man.